It has taken almost 40 years to erect this building in which are the offices of a factory in Berkeley, California. Almost 40 years to erect the framework and cement those bricks? No, 40 years to lay the foundation. Well, this building is built on experience. Experience in the ability to produce one thing: power. These engines are being run on their test stands for 8 hours. Actually, we know that they will run. We can tell within a few drops how much gas and oil they'll consume. The materials, the piping, the accessories have all been tested before. Why, then, is every single engine tested as it comes off the final assembly line? The answer to that question is our story. It is the story of experience. And the abilities of men as well as engines are on the test stands. Elliot Racklin, engine lathe operator. Harold Morris, chief engineer. Don Randall, sub-assembly. Walter Henderson, vice president. Bill Hartung, plant superintendent. Lee Scott, sales manager, and Wayne Farnsworth, field engineer. Jim Ross. Bob Palmgren, plant manager, and Merle Blankenship, production manager. Lou Davidson. Engineers Glidewell and Railton. The automobile and boat, which hold the world's speed records, are both designed by Mr. Railton. And they are on the test stand, too, all of them. Their skill, their ability, their loyalty. But there is more to the story of experience, and one man perhaps can explain this better than anyone else. We could use a lot of fancy words to describe management, but actually management's job is to put into effect what experience has taught us. We started taking lessons a number of years ago.
Yes, and sometimes we got an education in more ways than one. The Hall Scott Motor Car Company was originally formed to produce railway motor cars. An artist made this sketch of what he hoped the plant would someday be, but these vehicles were the first gasoline-powered railway cars we built. Then we and the product gained by experience in the artist's dream started to come true. We built the cars as well as the engines and learned many of the problems of the car manufacturers. The power plants were efficient, but because of their exceptional size for those days, presented many problems. For instance, we had to design, develop, and build a special transmission, still learning the hard way, originating, not copying. And the engines hauled maximum loads on railroads as far away as China. But even while the first cars were being built, we were also pioneering an aviation engine embodying overhead valves, a feature used in aircraft engines today. The gentleman in suspenders servicing the engine is our own Lee Scott, now sales manager. That aeroplane was flown by Mr. Masson, and he telegraphed, made 25 minutes at 3,000 feet. 25 minutes at 3,000 feet. Shades of the flying fortress, actually. For here is the first Boeing plane, powered by Hall Scott and designed and built by another man whose name is also familiar today. Glenn L. Martin. Yes, we all went to the same school together. Power was our subject and experience our teacher. We had thrilling demonstrations of unbelievable speed. We had lady daredevils. We had an Air Force. We had some queer ideas. And we had tragedy. But we also had progress. And what we learned about engines then helps us today just as it did when we helped develop the famous Liberty engine. Just as it did when Holt, which has grown into the Caterpillar Tractor Company, called on us for power. It started back in those days. If there was a tough job for an engine, it was a job for Hall Scott. Engines built for Faggio years ago still operate, some of them 20 years after installation. And experience led to our unit construction engine, which reduced cost of service maintenance to a new low. Development of our first horizontal engine started some new ideas about payloads. With the conventional truck, 96 square feet of payload space is available. With cab over engine, this is increased to 128 square feet. But with the horizontal engine installed under the floor, we have 172 square feet, an increase of 79% in available payload space on the same wheelbase. But the value of experience can be judged only by results, by the ability to produce power, which will operate under any conditions of weather or terrain and operate economically. That's why the engine under the hood of this truck of the Aero Transportation Company has a special significance. It has gone 2.5 million miles. Now we know that such mileage is as much a credit to good maintenance as it is to manufacture. But Aero bought it second-hand, after it had already hauled its loads for 1 million miles. We do not know of any other instance where such confidence has been placed in an engine that has already gone the distance of 40 times around the world. How many million miles still lie ahead of it? But long engine life is only one part of the story. We designed this offset cab truck around our horizontal engine. Complicated and excessive maneuvering is eliminated by front-end loading, and at the same time we gain valuable space for a given wheelbase. Long life and operating efficiency can be combined only through practical engine design. To many a design engineer, this drawing is to all intents and purposes the engine. To a shopman, forgings and castings are the engine. But to the truck or bus operator, this is the engine, and he is right. The blueprint can be a work of art. Parts can be gold-plated. It can run on the test stand like a Swiss movement. But the only thing that counts is on-the-job performance. And performance begins on engineering blueprints.
We who make the drawings know that our customers must carry capacity loads, that to operate profitably they must have sufficient power, economy of fuel and oil, economy of maintenance. When this engine is installed, any infinitesimal cylinder wall or crankshaft deflection, valve leakage or thermal distortion is multiplied to astronomical proportions as it turns actually billions of revolutions. A seemingly insignificant engine flaw can eat into an operator's margin of profit quite significantly. That is why our basic design principles are the same as those used in all aircraft engines, which are known as high-duty engines.